Hi, welcome to the Earth Science Classroom. Welcome back. This is a video on tidal bores. It's part of the tides series and part of both geomorphology and coastal geomorphology and also oceanography. So it can fit in different playlists. Now, tidal bores are an amazing natural phenomenon or phenomena which occur around the world. There's around 60 different bores around the world, depends on different countries and rivers and estuaries and tides, and they range in size between a few meters up to a max of around 10-meter height waves, which can move up the river and inland, which are pretty awesome. They are obviously linked closely with, obviously caused by tides, and the video is going to basically cover this. Going to basically explain what a tidal bore is and how they are created. So basically the functionality of the tidal bore. We're going to look at how they're going to form and where they're going to form, and also the different types. There are two main types. All right, join me now. All right, so tidal bores are basically walls of water, or called a hydraulic jump. Okay, so it's basically a wall of water called a hydraulic jump. It is associated with the flood current with tides. So it is controlled by obviously the sun, the moon, and the placement of the earth. And based on the other videos on tides, there are obviously hundreds of variables that go into it that dictate the tidal pattern. Spring and neap tides, and also is it diurnal, synodiurnal, is it mixed, and also the tidal range. Now, the tidal range also relates a lot onto the physical characteristics, the physical geography, and the topography of the coastline, and obviously the river estuary, the opening where the river meets the ocean. So as you can see by this lovely picture is you have this, obviously this way is up the river and inland. Okay, we have the river right here. We have this break-in tidal bore. Now this instance is not the largest tidal bore, it's more of one type of tidal bore, a break-in tidal bore, and you have some turbulence, some small oscillating waves behind it right here, and the tidal bore is going this direction. So the whole area of the river is basically allowing this tidal bore to move inland through or up through the river inland from the ocean. So this direction over here would be the ocean, okay, and this would be the flood tide, the flood current. And this actual bore represents the leading edge of the flood current. So if we draw a profile of this tidal bore, you have this increase in height of basically the depth has increased. So you have this leading edge right here, which is the actual bore, and it's moving at around 20 or up to 25 miles per hour in this direction up the river. This is due to the flood current, okay, the incoming tide. So in terms of occurrence, when do these happen? Well, they happen when the tide is rising and the ocean water is flooding back towards the land. And in terms of rivers, it can go up the river. As long as the river connects to the ocean, and that would create some sort of estuary, it's going to flow up the river, then on different characteristics. So this could occur daily, as with the high tide or the incoming high tide. So from low tide to high tide, it can occur. So occur daily, even twice per day. Now, the larger bores that are more obvious, you can even surf them, ride them. Some are very, very large. The river in China, which is pronounced, I'll probably butcher this, but Jiangtang River in China has a average of 4-meter high tidal bore. And these occur generally on the spring tide. This is when the tides are higher than average. This is during a new or full moon, where you have the alignment of the sun, the earth, and the moon. Okay, the alignment which give the increased gravitational attraction, gravitational forces. So what is needed to create a tidal bore? All right, we've got a nice little tidal bore right here. We have the Bay of Fundy, which has the largest tidal range in the world in Canada right here, and again has a nice tidal bore as well that occurs up a few of the rivers that branch off from the bay. Now, what is required? You need the high tide and the tidal and the flood currents. You need a large or medium to large tidal range. You need a wide and funnel-shaped estuary or estuarine area in order to basically channel and build up the amount of water to create this bore or this standing wave or this leading edge. So it's going to funnel and it's going to basically build on itself and go up the river with increased force all at once, which causes the wave to occur. You also need a tide dominated beach or area. That basically is you've got large tidal range, you've got a lower and gentle sloped gradient of the riverbed and the estuary that allows the wave to form properly, and the wave refraction off the edges of the estuarine bay is going to help to funnel and amplify the wave. And if you have a wave-dominated beach, then the waves could disrupt the wave frequency and disrupt the organization of the tidal bore, and thus wouldn't actually allow it to be created, or be created but in a very short time or for a short distance. Now, speaking of distance, there is a tidal bore called the, again, this is in Portuguese for the Brazilian river, the Amazon, which I'm probably going to butcher, but the Paroca River or tidal bore goes for 500 miles up the Amazon from the Atlantic, basically going west up through the Amazon River. And it's so powerful that the actual Amazon River doesn't have a delta like Mississippi. It just basically dumps directly into the Atlantic Ocean, rather than having this large, fanned delta like the Mississippi. You just have this dumping deposition area right in the Atlantic because this tidal bore is so powerful, and it goes for a long duration, long length. And the last kind of characteristic, you need a smooth seabed or estuarine area bed, and you also need a fast flood current compared to the ebb. So the ebb current is going to be slower. Okay, so slower tide moving out towards the ocean, but a very quick response and reaction tide coming in, called the flood current, much faster. So you get that large amount of water coming in all at once. You're going to have that increased level, and you're going to create the wave that is the tidal bore. So the two types of tidal bores, you can, in terms of formation, how these are formed, you can obviously, the main one, principal one, is tides, as discussed. The second one can also form through a tsunami. Tsunami induced in correlation with the tides. So put add plus tides. Now this could be a much more devastating and larger, but again, it can happen where the tsunami can induce with the high tide, with the flood tide, a tidal bore. Now, of the formation, you can get two different types of bores. Okay. Now, the pictures here on the bottom left and the top right, they are the same type of bore. So these are what we call regular tidal bores are breaking. Okay. And they're usually a single wave at the front with a much elevated surface behind it. Okay, like I drew earlier, where you have this this higher elevation, and then here's the wave, and then there's the river, and it's going in this direction. So you have this elevated area, and there's the riverbed. Okay, like that. So you have that tidal bore, that leading edge right there. So this is the type 1. Type 2, okay, which is called an undulate bore, which is a succession of multiple waves. Okay, and this is called a wave train. So there's still a leading edge. There's still that single wave at the front, which corresponds to the leading edge of the flood current. However, there are multiple waves behind it. So if here's my wave, there'll be other waves right here. It's drawn on this picture. There'll be like waves where you'd have the waves like this, and then there's the first wave right there, and then there is the river. Okay, you'd have these multiple waves, these wave trains, basically, coming after the first wave, and it will be a succession through or up the river. This is called an undulate bore. Now, these are generally smaller because the energy is spread over a larger area, so the actual initial bore, front bore, is not as large. Okay. Now these, the first type, the breaking waves, okay, you'll see obviously it's more turbulent right there. You see it's very turbulent, okay, and this is very characteristic of that first type. It's very turbulent breaking wave. So now whether you have two different types, the actual bore breaking wave or the wave front, the bore front is basically defined by an algebra equation. is called the Froude number, which is FR1, like that. Now, so this is basically if the wave front, if the algebra equation comes out to more than unity, which is a word that means one, okay, if it's more than one, okay, or much larger than one, then you're going to have a tidal bore created. And the size of this number will dictate which type of bore you have. So if you guys love the equations, all right, and your little math gets you excited, and here we go. All right. So we have the G, which is gravity. We have D1 and V1, which basically are the upstream internal flow. So the strength of the river, basically the discharge, right, of the river. If it's too great, it's going to basically destroy the bore. Okay, and then we've got U, which is the wave celerity, which basically is the speed, how fast the wave is traveling. Now, wave period is the time it takes for two crests to pass a certain point. However, celerity is the actual speed of the whole wave system moving up through the river. So this formula will give you, hopefully, a number greater than 1. Okay. Now, if it's between 1 to 1.3, then you get more of an undular bore with the wave train, and that's not very well-developed frontal bore leading edge. If the number is basically greater than 1.5, then you get the regular turbulent frontal bore with no real wave train, like here on the left or here on the right. Classic one that you can surf, and the classic ones that are much larger, the ones you get in the Severn River in England, the one in China called the Silver Dragon, the one in India, Malaysia, and obviously the one in the Bay of Fundy in Canada. So these tidal bores are definitely anything but boring. They are amazing natural phenomena. There's over 60 that happen around the Earth. Depends on certain characteristics of river, estuarine depth, and topography with the tidal current, tidal range, tide-dominated coasts, and getting this massive wave going up the river, sometimes 100 miles inland, like with the Amazon, and it's an amazing sight to see. It can happen daily or basically during the larger spring tides where the rotational pull is maximized. And yeah, hope you enjoyed the video. If you want more videos or announcements, please subscribe and leave a comment. It'd be great, and I'll get back to you on the comments. And I'll see you in the next video.